Hi everyone, my name is Mohammed Furkan. I am from Istanbul Medipol University, Turkey. The title of my presentation is Secure and Reliable IoT Communication Using Non-Orthogonal Signal Superposition with Dual Transmission. Starting from the need for secure communication, due to the broadcast nature of wireless communication, it is vulnerable to several security threats. As presented in the figure, it is observed that an eavesdropper can hear the sensitive information, and a spoofer can manipulate the data to cause accident. A jammer can disrupt the communication. In this work, we are focusing on eavesdropping problem. Starting from, as I explained earlier, we have three attacks: spoofer, jammer, and eavesdropper, and we are focusing on this eavesdropper. In the literature, the conventional solution to provide security against eavesdropper is based on cryptography. However, due to the heterogeneous network of future wireless communication, key sharing and management is challenging. Moreover, secret key, some of the algorithms also are based on computational complexity, and for future communication such as based on IoT, these complex algorithms are very difficult to implement. In order to solve these issues, physical layer security got too much attention. Physical layer security exploit the random characteristics of wireless channels such as noise, interference, and fading to provide security for future wireless network. Having said that, as I explained earlier, although due to the powerfulness and popularity, the current IoT is facing one of the biggest challenge as security. Uh, and Cryptography based techniques cannot be implemented efficiently due to the low complexity, lightweight computing, and power constraint of IoT devices. And physical layer security have the potential to provide security for such cases. Having said that, in this work, we propose an efficient physical layer security approach for providing secure and reliable communication in downlink multi-carrier IoT system. The system model consists of in our proposed algorithm, the system model consists of a transmitter that have two antennas but with one RF chain, so that at any time we can active one antennas, and we have two single antenna user. The transmitter is communicating with two single antenna user in the presence of an eavesdropper. We assume that eavesdropper is passive and his channel state information is not known at the transmitter. Now, the goal here is to design an security algorithm such that we can provide security from this external eavesdropper, as well as user 1 and user 2 will not able to eavesdrop each other data. In order to do that, the basic idea in our algorithm is that we will superimpose the signal of user 1 and user 2, where I1 and I2 are the input bits, and the resultant x1 and x2 are the frequency domain signals. We will superimpose these signal of user 1 and user 2 with the multiplication with a precoder, and we send them in two round. In the round one, as you see from this slide, that we will multiply in round one our signal x1 with M1A precoder and x2 with M2A, and in the round two we will send x1 x2 again with multiplication with another precoder. Now we will send our communication in round 1 this packet 1, and in round 2 this packet 2. When these packet received at user 1 and user 2, and they just combine them, we want to design an algorithm that there is no any complex computation is required to decode their data. In order to achieve this goal, user 1 will just add the data, the packet that he received in 2 rounds. And as you see with simplification in the third line of this first box, the first term is the desired term at user 1, and the second term is undesired term. Similarly, user 1, 2, and user will also add the signal from round 1 and round 2. An eavesdropper who is eavesdropping them will also receive the signal, and for him both data related to x1 and x2 are desired terms. Now we want to design precoder to achieve this goal. As I said that the first term for the user 1, the first term is desired term, so we will put it equals to identity, and the second term we will put it to 0. Similarly, we will repeat this process for user 2. By these 4 equations, we will design the precoder matrices for 2 rounds. And when we use these matrices and send our signal in 2 packets, we can achieve security against external eavesdropper, security against internal eavesdropper. And due to the diagonal channel matrix, the inverse operation is simple. Moreover, we are using 2 channels and 2 rounds. It will be very difficult for an eavesdropper to crack this or eavesdrop this communication. Having said that, coming to the simulation result, first of all, we are presenting bit error rate versus SNR curves for the proposed algorithm, where bit error rate Bob1 and Bob2 proposes the proposed algorithm. BERC, so we put it for comparison, where we are sending 2 packets and combining them. This is without security. We are just sending 2 packets from the transmitter, and the receiver is just combining them. Bit error rate CISO is a conventional OFDM, and it is observed from the figure that the performance of our proposed algorithm for user 1 and user 2 is similar to each other. However, there is a small degradation compared to CISO dual due to the design of our precoder. And our proposed algorithm is better than CISO. That shows that it provides a reliable communication. Moreover, we also observe BERE is for external eavesdropper, BERI for internal eavesdropper. It is observed that the performance of external and internal eavesdropper is very bad and worst. Coming to the second plot, it is throughput versus SNR. First of all, it is observed that Bob1, Bob2, there is a performance degradation because we are sending every packet 2 times. However, CISO have good performance because we are only sending once. But I want to mention here is that if we consider jointly for user 1 and user 2, our algorithm have similar performance to CISO. Jointly means that in 2 rounds at then we are sending 2 packets. Similarly, we also showed the effect of our proposed algorithm on PAPR, as it is observed that there is a little degradation due to the application of proposed algorithm on PAPR. In order to show the robustness of the proposed algorithm, we also present our plot for imperfect channel case. As you observe that there is a small degradation in channel. Finally, conclusion and future work. We propose an effective technique for reliable and secure communication where we use channel-dependent precoder with dual transmission approach for providing security and reliability. Simulation results prove that our algorithm can ensure secure communication for IoT-based devices. For future work, the extension of the proposed algorithm for active eavesdropper case will be considered. Thank you so much for listening.